Hello, everybody, and welcome. This is Professor Thayer with you here today to talk to you about the mini Python courses. So in today's lesson, we are going to see what the mini course is all about and also talk through some of the introductory material of our COMP112 course. So let me go ahead and get the slides for this morning up for you, and let's get started. Let me share screen more. Share. Screen. All right, there we go. Now let's see, we just need the slides. Wait, oops, Zoom window is blocking. There we go. All right, so this is our 112 mini course, summer of 2025, and today's first topic is the algorithms. So in today's lesson, we will take a look at the course overview. We will see about the regular 112 course, which is the counterpart that we offer during the academic year. I will be teaching all three sections that we're offering this fall. So maybe that's something you might be interested in joining us. And we'll also take a look at the mini course, which is a subset of the content of the regular 112. We'll also take a look at the course components and grading, the course policies, and a first look at programming. So let's have an overview of the regular 112. So the objectives of this course are to learn to think like a computer scientist. This means learning to read, write, and reason about simple programs. It's not simply about just learning how to write the syntax, right? Sometimes introductory students think that, it's just about learning how to make that syntax, but really what we're aiming for in this course is not just that, because of course these days we have ChatGPT and many other excellent resources that can generate code for us, and you just tell it what you want it to do. But if you want to go beyond that and you want to really understand how to do the logic of this, and be able to do this from scratch by yourself, that's what these courses are really all about. We're going to learn the mechanics of Python, so it does include some learning of the syntax, but also it is about understanding how to compose a program from the philosophical point of view, also a bit about how one composes this in a systematic way to represent a kind of logic. And in fact, if you do go on in computer science, much of the computer science major actually has a significant overlap with math, because there's all kinds of proofs and so on that you can actually write about the programs, which is maybe a bit of a surprise for some people, but this is it's very close, and there's no coincidence that Wesleyan's math and computer science departments are a bit twinned, being located in the same place and also sharing an awful lot of their resources. So we're also going to look at using programming to solve interesting problems. So we will learn how to break problems down into pieces that you could solve with the tools available. And then we would look at how we can synthesize those solutions by combining those smaller parts so that you will be able to create programs to do the tasks that you want them to do. So you can get Python from the python.org. This is a snapshot of their website, and you just go there and you can download the Python. So you'll have your download button right here. And in fact, when we do our first lab together, that would be exactly where we would start. So you're free to go ahead and test that out yourself, or we'll be happy to work on that with you. Python is written by Guido van Rossum, who is depicted up here. If you have ever used Dropbox, Google, or many other modern programming tools as an end user, you are very likely to have interacted with Python code. And this is just a silly little cartoon where a Python snake with a very full belly is slithering around saying, oh, so who is this Guido van Rossum? He actually has an interesting history as to how and why he was motivated to start Python, but basically to make a more readily accessible and easily usable programming language, which started off as a scripting language, but now is a real full-fledged programming language. So you might be interested in reading up on that in your spare time. Who is this Python course designed for? The audience is essentially people who have little to no programming experience. We expect that you have the basics, like you know how to turn on a computer, running programs, opening and editing and saving files. Although we recently have had some students who were working on a computer for the very first time and successfully completed my class. So it is possible. We don't expect that you have any programming experience, and we don't have any prerequisite coursework for this class. So it's appropriate for people who want to go on to the computer science major. Now, it is important you understand that this course, our regular 112 and of course the mini course, do not count towards the computer science major. So in order to gain access to the major, you do need to complete the 211 to 12 gateway sequence to get into the computer science major, which would then allow you to take all of the 300 level courses in the major and other 200 levels. But if you don't feel ready to do that yet, particularly if you maybe have not programmed much or not at all, then this is the place for you to start. So you can use this course to apply programming in the sciences, humanities, and arts. So you don't even need to have an intent to go on and take the major. And many of our students are not taking it because they want to be majors. They just take it for a general education, which brings us to the next point here. This does fulfill a quantitative general education requirement for the NSM, the natural sciences and mathematics. So if you are going for that certification, then this is one of the classes that is very popular to fulfill that if you are not a science major. You can also use this to fulfill requirements for certificate programs, and you can also learn how to program specifically with the Python language more in depth than the QAC option. So there is a QAC version of this course, which is more about the applications of Python and for data analysis, and a little bit less on some of the more detailed things that we will cover in this class, like thinking like a computer scientist. So this is just a brief list of the requirements 112 fills. It's not in fact required for anything, but you can elect to use it for a variety of things. And you can find out the details of this on the WesMaSS page. So I do encourage you to look at that. But some of the things you can use it for is you can apply it towards the biology, math, and neuroscience and behavior majors. You can use it in the data analysis, education studies, or ideas, integrated design, engineering, and applied science minor. There's also a number of certificates, certificate in applied data science, and then also in informatics and modeling, of which there are 2 separate tracks. And you can also use it in the College of Integrative Sciences, which is as an add-on major that allows you to design your own major. The book that we use is Alan Downey's Think Python. So you can download the book as a PDF for free. So you can just go and get that online. The link is down here. It's also on your Moodle page and in the syllabus. You could buy a hard copy at RJ Julia Bookstore or on Amazon if you prefer that. You should use the 2nd edition and not the 1st edition because they feature different versions of Python. We're using Python version 3, but the 2nd edition of the book. Now there is a 3rd edition of the book, but it is more like an interactive one using the Jupyter notebooks, which you also could elect to use, but you will not be able to get the free PDF. It would be the interactive version, and you cannot get it in hard copy. So we also have the Moodle website. Now, our Moodle website has the syllabus, the course calendar, the assignments. So this is where you'd get your assignments and post your solutions. Actually, now a lot of my assignments in the regular course, I have moved to a Google Drive, but all the links to it is right in your Moodle page. And for this one, all the assignments are right there on your Moodle. this is where you would get your grades and where you would see your solutions. We also have the lab assignments. So again, we point to our labs for this class. I have them all just right on the Moodle, but otherwise they would just be linked to the Google Drive. You'd post your solutions here, and this is where you would pick up your feedback. If there are any notices, they may be here, although typically I just email everybody. And also the slides from the lectures are also linked from here. The topics covered in the course would be algorithms, variables, and statement strings, processing, so if and while loops, functions, lists, dictionaries, file input and output, and object-oriented programming. So this is for the complete course. Basically, we get up to the these topics right here. So list, dictionaries, file IO, and object-oriented are in the second half of the course. So basically we divide it into 2 sets of lectures. In the beginning, it tends to be a little bit nicer and easier to get started with this, but it does pick up. And then we work into some of the more advanced topics, which are some more advanced data structures, and also working with file input and output. And Python is, in fact, an object-oriented programming language, so we do a section on that, although there is much more one could say about OOP. Now, let's just reiterate that the mini course is not graded. It is for your personal edification, but this is how it is designed. So there'll be 2 exams, a lab session, homework problems, and the final project. So this is what is in our main course, and that's how things are divided up. So obviously the exams do carry a lot of weight and are equal to your final project. You might say, oh, well, you know, why should I work so hard on the lab or the homework? Well, the reason is because that is where you're going to get your practice for doing really well on your exams. So this is a little bit about me. I teach a number of courses that you may see me in. So the regular 112 is the place you're most likely to encounter me. You could also see me in some other courses as well. So I also teach working with high performance tools, which is appropriate for you to take after you complete the regular 112. This is to work on Wesleyan's high performance computing cluster. Did you know we have one? Well, we do. And that's something that is a very unique opportunity at a school of our size. So it is useful if you want to get up and started on working on that. You might want to take that class. I also teach MATLAB, and I also teach in the chemistry department. So you may see me in physical chemistry for the life sciences if you are a chem or MB&B major in the upper level course. A few fun facts about me. I'm a graduate of Wesleyan, so I got my PhD here some years back. I also love animals, so I have rescued 3 greyhounds so far. You can see some of them pictured over here. My current one, Hemi, is a black greyhound represented by this one, and I also have quite a few aquaria. All right, so about the mini course, we'll have 4 lectures in the next 2 weeks. So the way this is going to be set up is lecture 1, this one will be about algorithms when we get into our content, and lecture 2 will be about variables. And then next week we will do the statements and functions lectures. We also have the labs, so the lectures will be on Tuesday and the labs will be on our Thursday meetings. The schedule is that, oh, okay, yeah, this is actually not updated. I apologize. 8:30 to 9:50 is our lecture time. So we will hold these at this time. We will do the first lecture, take a break, and do our second lecture. And then on Thursdays, which will also be at the same time, 8:30 to 9:50, not 1 to 2:20. Sorry, it's posted correctly on our Moodle page, but not here. We will also have some problem solving, and we also have some office hours available after the lectures or by appointment. Just let me know if you would like to discuss something. How to post your solutions. So the problem sets are due on Thursday at the lab. So you would post your solutions to the Moodle to receive feedback. Again, it's not graded, so there's no punishment if you don't do it or get it wrong, but it's a low stress, fun way for you to learn about the course. And also, if you do take regular 112, it will give you a head start because some of the problems might look kind of similar to ones we're doing in the real class. All right, so let's dive into some actual content here. Let's take a look at programming. So this is a Python snippet of code written by an actual student. This is their final project after they took the whole class. Now, of course, you don't know about Python programming yet, but I bet you could look at this and probably understand a few things. So let's see what we have here. Looks like they're having a game. Welcome to a Monster Ball shop. How can we help you? Now, we see that it looks like there is an option to buy a Monster Ball. So we will print out this message to the user. Now we have this while true construct here. This is going to continue doing something until the user gives a response. So let's see what is going to be happening here. So you'll see that we're going to be getting some input from the user to either buy a Monster Ball or leave the shop. So you see this will be stored in a variable called do. If it's 1, they picked 1, then they're buying the Monster Ball for 30, and it's checking to make sure they have enough money. So it's supposed to be $30. Otherwise, if do equals 2, then it's going that means they chose to leave. So you see we get the message, thank you for coming. And we always have to make sure that we dummy proof our code because we tell the user to type 1 or 2, but what if they type something else? So here is the check using the else. So this would prompt the user they are supposed to pick 1 or 2, and because this isn't a while true loop, it will keep asking them. Now, you may not have been able to write this yourself at this point, but I bet you could look at this and you can get an idea of what's going on here. This is very useful because oftentimes when we are programming out in the wild, we may not always have experience using the exact things that are being used in that code, but we can look at it and we can figure out what is happening here. And as you go through this course, you will learn more and more about how to do these things. So why should you learn to program? So maybe you want to interact with your computer on your own terms instead of being beholden to just some buttons and whatever apps somebody else already made. We also might want to automate repetitive or boring and laborious tasks. Bring your ideas to life. Computers are really quick and can get things done faster. And why do you want to learn how to program? The reasons why people choose to study this are quite wide and varied, and be interested to find out about why you are interested in programming. All right, so let's take a look at the imperative programming languages. Imperative programming is the kind of paradigm you're probably thinking about when you're thinking about programming, but it's important to realize that there are more than just one kind of programming. So imperative programming is when you explicitly tell the computer what to do and how to do it. So in order to do this, we will need an algorithm. So in other words, this is the kind of programming where you say, go to this line, do, print this, calculate x plus 5, and if x is greater than 19, then there's something to do, right? So this is the kind of programming we oftentimes think about. So this allows us to communicate an algorithm to a computer by writing that program. So imperative programming languages are Python, C, Family, Fortran, Basic, and even some of MATLAB. But in the age of AI, it is important to realize that there are many other kinds of programming out there. So think about artificial intelligence and machine learning. That's an example of declarative programming. This is where we tell the computer what we want to happen, and the computer figures out how to do it by using neural nets and other ways of doing it as well. But this kind of programming is a very interesting kind of coding, and that is not the kind of coding we'll be doing here. We're going to start with the more basic kind, where we want to tell the computer exactly what the steps are in order to solve a particular problem. So this is an example of an algorithm. This is Euclid's GCD algorithm. Now, If you recognize that name, you're from math class, you're probably aware that you could live long before computers were even invented. So how could we have an algorithm before computers? Well, an algorithm is really just a way of how to solve a problem. It is the step-by-step delineation of how to do that. And one of the first questions I will ask you to do is to write an algorithm for doing a simple everyday task, like how to make a ramen noodles or a sandwich or whatever task you would like to choose. And obviously, you're not going to have your laptop make a sandwich for you, but we can write an algorithm for that, which are the step-by-step instructions on how to do it. And so this particular flowchart takes you through how to compute the greatest common divisor, a task probably familiar to you from your middle school math. And as we see, it is a series of very particular questions and variables, and that combination of these instructions is then what allows us to determine the outcome. So what we will be doing is working on that algorithmic thinking to come up with, how do I actually solve this problem? And then we will need to go from that algorithm into communicating that to the computer, which is where writing the Python scripts comes into play. So this is a quote from Atticus Finch. You might have read Harper Lee's To Kill a Mockingbird. And so I bring this up because we'd like to talk about parsing the syntax. So we will, of course, be studying a bit of the Python syntax throughout the class, and getting the meaning out of the syntax is oftentimes one of the most important things to consider, because we write the syntax with an intent, but that intent may not be incorrectly interpreted by Python. So syntax is something that expresses the idea, but parsing is the extracting of that meaning out of the syntax. So if we do not correctly write the syntax for the parser that will be used in order to extract that, then we may get unexpected results, and this oftentimes leads to the errors that we may encounter while we are coding in Python. Here's an example from math, order of operations. So parentheses, exponents, multiplication and division, left to right, addition and subtraction, left to right. That's the order of operations. I'm sure you've studied this before. You may have some mnemonics like, please excuse my dear Aunt Sally, or others that you learned in order to figure this out. But of course, this is simply just a system that we have all agreed upon, that these are the orders that we will use. There's nothing that says that a parenthesis needs to group things, right? So we all just agree that this is what the syntax means. And so then we might call to mind a typical exercise in your early algebra days, like 1 + 2 × 3, where the beginner will be very tempted to add 1 + 2 to get 3 and then multiply that by 3. But I'm sure you know that this is wrong, because that invalidates the rules of operation, which requires you to do multiplication and division first. So you would first multiply 2 × 3 and then add 1. And so we can then see that we need to, in fact, impose a parsing order in order to correctly evaluate the answer to 7, whereas if we don't follow those rules, we may get to something else. So a lot of what we'll be doing is trying to understand Python, and Python is very algorithmic. It does exactly what you say, not what you intended for it to do. And so this is why learning the syntax of Python will be very important. All right, well then, that brings us to the end of our first lecture today. We have talked about imperative programming, algorithms, a bit of syntax, and how to parse the syntax. I hope this has been a great taste of Python to get you started. We will have another lecture in a few moments. So if you would like to join us for part 2, feel free to take a break, and we will be back with you shortly. Enjoy, and we'll see you soon.